Hi friends, welcome to Making Things Fun, Cool, and Sexy. I'm your host, Christine Holly Ngo. I have a dear friend in the manufacturing industry as my guest today. He runs a heat treating and brazing facility that runs 24 hours a day, 7 days a week here in the Bay Area. Let me please welcome the CEO and president of ThermoFusion, Glen Ottinger, onto the show. Hello, Glen.
Thanks, Christine. Thanks for the invite and the warm welcome.
Yes, so happy that you're here. When we first met, we shared about our mutual interest in helping our customers succeed. And I knew that we would be friends, and I knew that there was so much for me to learn from you. Can you share with the audience how you got into manufacturing?
Yeah, that's a great question. I grew up working in a stainless steel foundry in Pennsylvania, and I'd swore I'd never work with metals. My dad made sure I had the hardest jobs in the factory and held me accountable to that, and it was a big part of my growth. But come full circle, my grandfather worked at Bethlehem Steel, my dad's a metallurgist, I'm a material scientist, so I found myself working with metals, and now I enjoy it. But it was that was part of my journey of to go away from it and then come back to it, and now I've fully embraced it.
Yeah, I mean, I went from Hollywood, right? And then now I'm back in the family business doing manufacturing.
Your shift is a big one. I like it. Your story is great. It's such a great one. I love it.
Yeah, so grandfather, father, and now you.
Yep, all in the metals. Yep, it's in my blood.
Awesome. So at ThermoFusion, you guys do brazing and heat treating. What exactly are those two? What is brazing and heat treating so that the audience can understand it?
That's great. So brazing is really similar to welding. It's joining two metals together, and it's using a dissimilar metal. So usually with welding, you're going to use a rod and melt it in there, and it's the same as the parent materials. Whereas brazing and soldering, they're really similar. You're using a different metal like a tin, a silver, or gold. The interesting thing about brazing is the Egyptians were doing it thousands of years ago. They were brazing copper together with gold alloys. So it's been around forever. We see it used mostly in heat exchangers and cooling plates. Then on the heat treat side, heat treating is heating and cooling at a specified rate to get the right properties out of a material. So it makes the parts better. Now, that's your definition, what better means. So when I think about that, some people want it softer so they can cut it, keep it flat. Some people want it harder so it lasts longer. And then sometimes it's just to remove the stress from, say, welding or machining.
So we have used you, not frequent enough, but for heat treating purposes. So when we machine steel, we want the material to be heat treated because the stress will be relieved from that. And then once we machine it, there's less warping. So that's how we have used your services before. But again, not enough. What fun, cool, and sexy parts do you get to work with at ThermoFusion?
Oh, that's a great question. I think what keeps my interest is that we're a tiny sliver of lots of people's manufacturing process. So instead of just being one line making a widget, we get a small slice of everything. So last year we got the privilege of working on a new biomedical device that helps treat sclerosis of the arteries where they're closing up, and it's growing, and people are that might have had a toe taken off due to circulation issues, this is helping solve that. So that's been a really cool one to help the medical community be able to make that.
Wow, changing lives, right? Like that's what I love about manufacturing is it's so fulfilling working on industries where we're making an impact.
Yeah.
And you and I, we've had multiple conversations about skilled labor and how the next generation, how do we get more people excited about manufacturing, about the cool jobs that are in our industry? Anything that you can think of?
Yeah, I think it's just exposure, right? Like so many people end up in manufacturing, and like we've already talked about, it's not a linear path. It's kind of like we did some different things and then like, hey, that's pretty interesting. And I also just think making stuff and having a product at the end of the day is so rewarding. Like, I think that's probably one of the best things about it is how rewarding it is.
I know, it's so rewarding for me that seeing raw material and then it becomes something is so rewarding. And then once we see it in an actual running system.
Yeah.
So cool.
I love that you're always out on the floor getting your hands in there.
Yeah.
It's awesome.
Yep, we try to. You shared with me that you bought a 3D printer for some of your kids at home to play with. How is that going? Do they have a lot of fun building things?
Well, I brought you a little gift from them.
Ooh.
So there's 2 gifts, but
I'm excited.
is this your first gift on the show?
It is.
I'm glad I can be that. All right, that's not the one. We can get to that in a second.
Ooh. Oh, this is so cool.
So for Halloween, our family was Star Wars, and there's your very own lightsaber. If you give it a swing, oh, you got to swing it harder than that.
Okay, let me use the muscles.
But my
Whoa.
12-year-old son 3D printed that. So found the files on a repository, and then obviously, like everything, takes some engineering to get it to actually work. And so there, your very own 3D printed lightsaber.
This is so awesome. What kind of printer do you guys have at home?
It's a Creality SE CR6. So, but it's just melting the plastic
This
in
is
there.
so cool. And how many hours did this take to print?
I think it's about 12 hours for each one. It's depending. Actually, funny story is he printed one for himself first, and it took a while and it was high quality. And I was like, well, we're all Star Wars. You got to print them for all of us. He figured out how to trim the quality down for the rest of us so that his was the strongest and the best.
How funny. See, he gets it.
Yeah, he gets it.
He knows how it is.
Yeah.
This is so cool. And was this printed on one printer or was it 2 different? Because I could see the material.
Different. Yeah. So we printed gray first. And actually, one of the hardest things to print on there is that cap on the bottom screws off. So to get threads that actually fit on a 3D printer is quite a challenge.
Wow.
So he figured out how to, that everything needs to be sized down like 2%. Otherwise they are too big. And
that is so cool. Threads, guys, threads on this.
So.
Wow.
Yeah.
And how old is your son?
He just turned 13.
Cool. He should be making parts and selling on Etsy. That could be a side gig. Cool, and then what is this?
Oh, that's a pen. It says 1% better every day. And one of our core values at ThermoFusion is hone your craft. And I think the way we say that is, hey, we want to get better 1% every day. And that's a James Cleary quote from Atomic Habits.
Yeah.
But just that idea of can we bring it, and that feels like it's at the core of manufacturing, is just like, how can we get a little bit better, a little bit more efficient every day? So that's my gift to you, that,
Oh, thank you.
Hone your craft. That's what our leadership team and the rest of the company's doing at ThermoFusion.
This is awesome. And this book is on my to read list, Atomic Habits, because I agree, like even 1% better. I don't think you follow me on Instagram yet, but I've been trying to run at Barry's, and I increase increments by like 0.1, right?
Yeah.
Every time I work out. And at first it just seems so small because at first I ran up to like speed 9 and I was like, wow, this is huge. And then one of my girlfriends, she's like, Christine, you could go faster, try for 12. And so like I was like, oh, how am I gonna do 12? But like little baby steps every day. And then I documented it, and it turned out that like by taking small steps every day, huge difference over time.
Yeah. Well, I have a friend that coaches wrestling, and that's what he always told his wrestlers, just bring it 1% better every day. And if you do that 365 days a year, the reward, the benefit is 30x, right? It's over 30 times. So I think everybody would love that from their investment accounts with money, but even better, bring it to work every day. Yeah.
Or if you're 1% better every day for 100 days, that's 100% better. All right, so now back to the nitty-gritty stuff of manufacturing. Mm-hmm. And let's just keep things real. In 2023, it was difficult for manufacturers. It was difficult for us as well. A lot of vendors and partners, they were sharing that they were losing 20 to 40% in revenue last year. Do you think things will be picking up in 2024?
That's a good question. I think if I knew that, I'd be on Wall Street and not in manufacturing. I hope they do. I do think the shops that are hit the hardest were focused in the semiconductor industry. Mm-hmm. And I know I have some customers that were down 60 or 70% for parts of the year, and that hurts. Fortunately, we were able to diversify into medical. I know you're in medical, aerospace, and so as semiconductor went down, those actually surged and kind of helped us out from feeling the hurt so bad, but it definitely was a tough year. I think our goal is anytime there's a downturn, 90% of the companies really feel hurt, but there's 10% that can really use it to springboard themselves into something better. And that's our goal, is to figure out how to be that 10%.
Exactly. And the semiconductor industry, thanks for sharing that. Like, we don't support semiconductors or that industry at all, but it really affected us because other machine shops became extremely competitive with their pricing, slashed their pricing down. And so, so the audience can understand, right? Like, let's say a big machine shop, they are dependent on the semiconductor industry. Last year, semiconductors paused on a lot of big orders. And what had happened were the bigger machine shops, they were not busy. So what they tried to do was to cut pricing down so that they can diversify and get into other industries, which means that they would need to compete with machine shops like ours and other machine shops in other industries. So we were really impacted by that. And hopefully things will change this year and the semiconductor industry will start ordering again. That's the rumor on the street right now.
Well, and what you're talking about, right, is supply and demand. That all of a sudden now there's a lot of extra supply on the machining and manufacturing side. So then prices go down, right?
Exactly.
It's not that people aren't buying chip equipment. It's that due to the supply chain whip of everybody was short on things in 2021, they overbuilt in 22, and now they're running through their inventory in 23 and 24. I mean, I believe there's over $200 billion in investment in fabs coming up, and they need that chip making equipment, the applied materials, the KLA, the Lam Research, and ASML. They're going to be buying all that equipment, and a lot of the parts for all that equipment gets made here. ASML makes the extreme ultraviolet lithography, and it is the most expensive piece of manufacturing equipment in the history of the world. It's $100 million per machine, and it's able to etch at some crazy nanometer resolution that nothing else can do. So, but a lot of that's here in the Bay Area.
And right now with AI, right, so big, and in order to keep up with the AI demand, we need chips to make these AI. I briefly did some reading about this. I'm not an expert whatsoever.
Above my pay grade too, yeah.
Yeah, but they also need to make chips for AI. So that will hopefully increase a lot of demand for that.
Yeah, and the cutting edge chips for sure.
Do you know how we could have local manufacturers and businesses support local manufacturing more? Like, besides going overseas, because we get that a lot. Like, we will do the prototyping, and once it goes into production, for the most part, businesses will go overseas for that to cut costs. Do you think there's anything that we can do to help promote this, to have businesses support local manufacturers?
Yeah, I don't know if most companies have a good way of evaluating that. I think it's just the assumption that it's cheaper to make there. But I haven't, when we talk to customers, it doesn't seem like there's actually a really in-depth comparison of the total costs. Hey, engineers flying over to Asia repeatedly to fix it. Hey, supply chain delays, if the longshoremen strike or any of those things that have happened in the last couple of years, or COVID, right? The ships were tied up. So I think, like most things, good data would help solve it, but I'm not sure how to get that. That's a gnarly problem.
Yeah, but no, like maybe once they're more aware of that, right? When you're sharing this and they see like there's other costs affiliated to offshoring to Asia on parts. Like, let's say if the parts were bad, and then they have to rework it. That's time. That's money. If they choose a local manufacturer, we can help them right away. If there's something wrong, we're right here to.
Yeah, and I think some of the semiconductor players are testing the waters with that. They've started to move some of their production and manufacturing to Asia. I think that's at the request of the Asian governments. Hey, if you're going to make the chips here and have your fab here, I want the equipment made here. And it's a lot of geopolitics behind that. But there is some stuff being reshored due to that, right? The U.S. wants to keep its competitive advantage in the defense area, so they want it made here in the U.S., which is a good thing.
Yeah, I didn't know that, so thanks for sharing that. Awesome. And like you said, in manufacturing, self-development is something I see pretty common amongst leaders, and I'm really into self-development. I like to ask my guests questions on like what failures they had to go through in order to become successful, because in order to be excellent, you just have to learn how to get up a lot quicker. Any failures you'd like to share?
That's a tough one. I mean, I think there's always things I'm trying to get better at, and I would see them as failures from, you know, whether it's how I lead the team or how we run our offsites. I mean, it's just, like I said, honing the craft, trying to get 1% better. Because I think leadership, it's really hard to feel like, oh man, I nailed it 100% of the time. So it's just going back, getting the hard feedback. And I think you kind of have two choices when you get that feedback. You can ignore it, or you can go, oh no, this can make me better, right? I think, it's not if you fall, it's if you get back up. But as far as like a failure that I'm like, wow, I really turned it around. No, I think it's just that commitment to be a lifelong learner. And that's really the key that I see to leading well. Yeah,
and just being open to making mistakes and like how to detour quickly.
Yeah,
right?
What's yours? I'm curious. What's your big mistake that like you've been able to like really embrace and move forward with?
So within manufacturing or machining, this was also another guest. She shared the same, but we didn't diversify at first. We just kind of like banked on maybe 2 to 3 customers and like depended on that. And every time there was a dip, it really affected us, you know? Yeah. So what we are doing now, we're diversifying where we're not solely just in medical, and we have other industries, so that we, like when one industry kind of tanks, we are still okay, right? So like that's something that we had to figure out, and it was a failure that turned into a success, you know?
Yeah.
Yeah.
Well, that's great.
And where do you see ThermoFusion in 5 years?
That's a good question. I think we are committed to growing, but we want to do it by building a solid foundation with our team. So we've been spending the last 2 years really building out our leadership team, being open and honest with each other, really working through getting things operationally right inside the business so that we can take on that growth and continue to grow. We've also launched a new vacuum aluminum brazing surface, and that's going to have a ton of potential, and we're already starting to see the fruit of that. So we see continued growth and probably a second site in our future. So we're trying to figure out where that might be.
Yay, awesome. Congratulations on that.
Thank you.
Can you share a little bit about the aluminum, what you just mentioned?
Oh yeah, vacuum aluminum brazing. So most brazing is done in a vacuum or hydrogen furnace, or you could do it with torch, right? But the key is to remove the oxides from the surface of the part so that you can join it. When you do it with torch, there's a flux that'll actually pull the oxides off. It's just an acid. And vacuum, it's the vacuum environment that pulls it off. For aluminum, as you know, as soon as you cut it, there's an oxide on that surface, and so it prevents it. So you actually need special equipment that's just dedicated to brazing aluminum. And as we know, more and more things are being made out of aluminum, and so we see a big trend going that way. And so we've invested a lot of money in moving forward with brazing in vacuum for aluminum, and yeah, we're excited about it. We're also integrated, as most shops are either a brazer or a heat treater. We've integrated them all under one roof so we can help our customers reduce their lead times, because after it's brazed, it usually needs to be heat treated. So we can keep it all in-house and turn it faster than most of the other options.
Oh, yay, awesome. We're gonna get to go on a tour of ThermoFusion soon. Can't wait to see this aluminum vacuum equipment that you just got. Thanks so much for coming on the show, Glenn.
Thanks for having me, Christine. Couple of things. So this is just a tube sheet assembly. It's some sort of heat exchanger. and we're just brazing these tubes into a stainless plate. It's all 316 stainless. So,
okay.
And they're leak tight, so they're in there.
So you brazed this?
Mm-hmm. Yep, that's brazed with a nickel alloy.
And explain to me, why is it different from welding?
Welding, you would need like that fillet around it, right? But that would be pretty hard to weld to get in there, either manually or with a laser. I mean, maybe a laser can do it nowadays, but this is nice because you can we'd put like a ring of preform. You can assemble it all cold, and then you just put it in the furnace and like kind of run your recipe, kind of like baking cookies after you get it assembled. This is for cleaning teeth. It's a dental pick, and it's really hard so that it can scratch the plaque off your teeth.
So you hardened it by heat treating it.
This is an air cool heat exchanger for an electric motor. Tiny fins in here pull the heat out from the core.
And this was also brazed, you said?
Those are pedals for a cart.
Oh, okay.
And they bend them, and they were getting stress corrosion cracking if they weren't annealed. So he's prepping them. So this is a vacuum furnace, so instead of pushing the gas out, it just sucks it all out, right? So that one's pushing the carbon gas out the front door.
Okay.
This one has 4 pumps, and it just pulls all the air, so it's a vacuum-like space inside. So, and we've got 1, 2, 3, and then a 4th on the other side. The vacuum of aluminum brazing is going to reduce the oxides and allow the 2 aluminum pieces to be joined by a different type of aluminum. We do that by pumping down a deep vacuum, and then we put magnesium in there as a getter. The magnesium vaporizes and sucks up all the oxygen, combines to make magnesium oxide.
Wow. Did you have to study chemistry in school to understand all of this?
Yeah, material sciences, chemistry, physics, and math put together. So,
wow, because one wrong molecule could blow up.
Yeah, and the magnesium, right, we have to have special fire extinguishers because magnesium will burn in air.
Okay.
And if you have a magnesium fire, it's a metal fire, and it's really dangerous, and regular fire extinguishers won't put it out.
Wow.
So.
How big are some parts that can fit in these?
Yeah, so it goes 62 inches back, 39 by 40, so it's a really large work zone. Most of our furnaces are much smaller than that.
Okay. So this is one of your newer equipment?
Yep. Awesome. Less than 2 years old. You can actually see the runs and all the data.
Very cool.
And has all the variables, so how much output of the furnace, temperature.
For each one? For each furnace?
Vacuum level, every furnace. So it has like the whole shop format, right? So we built it when the computer was facing the other way. So if you like transpose it like this furnace is in the back corner, and then like this one's right there. Basically for every, I think it's like 80 millionths of an inch, is 1 point in hardness. The more it resists indentation, the harder it is. And this is like the gold standard of heat treat is hardness testing.
Yeah.
The only one is tie. Tie, you can get the right hardness, but have the wrong mechanicals. Like it could still be really weak, but you'll get the right hardness.
It's heat treated in here.
Yeah, so it's a special atmosphere to keep the carbon. Then it slides forward and there's 1,000 gallons of oil it drops in.
Oh, wow.
So that's the carbon gas that keeps the metal from decarburizing during the heat treat process, which ultimately makes it keep its strength. We can also carburize out of that furnace, which means we increase the carbon potential and drive it into the surface.
Glen just gave us an awesome tour of ThermoFusion. Thanks again, Glen, for showing us all of your equipment, all of your furnaces.
It was my pleasure.
Thank you.